In this example, we're going to solve the polynomial system x minus 4y equals 5 and y squared plus xy equals 10. The first thing we notice is that the first equation here is linear both with respect to x and with respect to y. So this is a linear equation with both respect to x and y. That means that I can express x as a function of y, and I can express y as a function of x, whichever I prefer. Now, you're going to, as you can see, x has a coefficient 1 in front of it, so it makes more sense to express x as a function of y. That will be easier. So I can solve the first equation for x by setting x equal to 5 plus 4y. I'm just taking 4y, the term 4y, and I'm transferring it to the right hand side. When I transfer negative 4y to the right hand side, it becomes plus 4y. Okay, so now I have solved x as a function of y. Next, I have not used the second equation so far, so let me copy the second equation. Y squared plus xy equals 10. Now, I already know from the first equation that x equals 5 plus 4y. So what I can do is I can substitute the variable x away in favor of the variable y. So I can replace the variable x with 5 plus 4y. Once again, we found that x equals 5 plus 4y from the first equation. So now my second equation becomes y squared plus 5 plus 4y times y equals 10. Now this equation is a single variable equation, and we can use techniques from polynomial equations in one variable to solve this final equation. Okay, so first let us distribute 5 plus 4y, the whole thing times y, equals 5y plus 4y squared. We can also transfer 10 from the right hand side to the left hand side. Of course, when 10 is transferred to the left hand side, it acquires a minus. Okay, now let us combine y squared and 4y squared to 5y squared. Now this is a quadratic equation in y. We get the equation 5y squared plus 5y minus 10 equals 0. That quadratic equation can be directly solved. However, before I proceed to solve the quadratic equation, let me notice that all three coefficients, the constant term, the coefficient of the linear term, and the coefficient of the leading term, all these three coefficients are divisible by 5. So let me divide both sides of that polynomial equation by 5. On the right hand side, I get 0 divided by 5, so on the right hand side I get 0, and on the left hand side 5 divided by 5 is 1, and 10 divided by 5 is 2. So I have simplified my equation to the quadratic equation y squared plus y minus 2 equals 0. Now this quadratic equation can easily be solved with a quadratic formula. However, this quadratic equation has an easy factorization, and you can guess that easy factorization with greater ease than using the quadratic formula. So, can you guess a factorization of y squared plus y minus 2 for me? I'm sure you guessed it correct. You get y minus 1 times y plus 2. Once again, how we guessed that factorization, the numbers that we tried here were the numbers plus or minus 2 and the numbers plus or minus 1. So these were the two numbers we tried, and then we quickly uncovered the parentheses in our head to check that the correct factorization is y plus 2 times y minus 1. Our factorization is complete. Next, get that either y must be equal to -2, that we get from the first factor, or y is equal to 1. So our solution branches into two cases. Case 1, y equals -2, and case 2, y equals 1. In the first case, well, we are not quite done because we haven't found x yet. However, we remember that x, from the very beginning, we found that x equals 5 plus 4y. So x equals 5 plus 4y, but we just found that y is equal to -2. So I can replace y with -2 to get that x equals 5 plus 4 times -2. In other words, x equals 5 minus 8, and 5 minus 8 is -3. So our final answer is x equal to -3, y equal to -2. This is in one of the cases of the solution. In the other case, y is equal to 1, and again x is equal to 5 plus 4y. So this implies that x equals 5 plus 4 times 1, which implies that x equals 5 plus 4, which is 9. So our solution is complete. Let us collect our results in a final answer. Our final answer is either x is equal to -3 and y is equal to -2, or x is equal to 9 and y is equal to 1. So we got two pairs of solutions. Now that we have our final answer, let us very quickly check our work. So here's our final answer: x equals -3, y equal to -2, or x equals 9, y equals to 1. Okay, so let's check the first one. Let's check x equal to -3, y equal to -2. So what I'm doing is I have copied the first polynomial here, x minus 4y, and the second polynomial there. And now in those two polynomials, I'll carry out the substitutions. X I'm going to replace with -3, and y I'm going to replace with -2. So I get, on the first line, -3 minus 4 times -2. And on the second line, I get -2 squared plus -3 times -2. So on the first line, let's see what I get. -3 minus 8. So on the first line, I'm getting -3 minus 8. So I'm getting -3 plus 8, which is indeed equal to 5. And on this line, I'm getting 4 plus 6. -3 times -2 is 6, which is indeed equal to 10. So indeed, I do have that x minus 4y is equal to 5, and y squared plus xy is equal to 10, exactly as was required to solve this system. Similarly, let's check the answer: y equals 1, x equal to 9. So let me replace x with 9, and let me replace y with 1. So what do I get here? I get 9 minus 4 times 1, so I get 9 minus 4, which is equal to 5. Here I'm getting 1 plus 9, which is equal to 10. So indeed, for the second answer, y equals 1, x equals 9, I do get the correct output when I replace x and y with the corresponding values. So this checks my work and completes our problem.